Okay, so today we're just going to review the properties of equality. We have 4 properties, as you can see on the screen, and then we're going to practice with 4 problems for each one of these types of properties. So this is just going back to solving equations, which we have been practicing now for a little bit. So with the addition property of equality, we can see in symbols if I have A equals B. So remember, A and B are just numbers. We just don't know what they are. They're placeholders. So we have a number equaling a number. And then we have a number plus C equals B plus C. So I have A and B, and I'm adding C to both of them. I know they should have gone down to the next line so you can actually see it kind of like this. I think that would have been a little nicer, but for whatever reason, this is how they made the table. So if you can see, we're adding the same number to both sides. So if I know the two numbers are equal, and I add exactly the same thing to both sides, then they're still equal. I'm just increasing them by the exact same amount, right? Which is exactly what the words say here. Adding the same number to both sides of an equation does not change the equality of the equation because we're increasing both sides by the exact same amount. So they were equal before. I increased them by the exact same amount. They're still going to be equal. They're just going to be a little bit bigger. Subtraction property of equality. So this is the exact same idea. We have a number equaling a number, so A equals B. But now I'm subtracting C from both sides. So I had two numbers that were equal to each other, and I'm taking away the exact same amount on both sides there. So they're still equal to each other. They're just a little smaller now, right? So subtracting the same number from both sides of the equation does not change the equality of the equation, right? So these are just things that we can do with an equation, and these are undoing actions when we start to get into solving an equation. So if something is being added or subtracted, I can do the opposite of that operation on both sides of the equation. Remember, if I do it to both sides, I'm not actually changing the equation. I'm just increasing or decreasing on both sides. So it's still equal. But what it does is it undoes the operation on the side that I want to move it from. All right, multiplication property of equality. So I still have A equals B. C cannot equal 0 in this situation. So I have A times C equals B times C. So now I'm multiplying C on both sides. I'm multiplying by the exact same thing. So again, they were still both equal. I'm multiplying the same thing on both sides, which means I'm increasing again, just like I was with addition, but I'm increasing more, quite a bit more. Usually multiplication is a bigger jump than addition. So multiplying both sides of the equation by the same number other than 0 does not change the equality of the equation. Whoops, didn't mean to go forward yet. Division property, same exact idea as the multiplication property. We have A equals B. C cannot be 0, and I can divide both sides by the same number. So just like subtraction, this is going to make both sides a little smaller, or maybe a lot smaller, depending on what we're dividing by. But I'm still dividing by the exact same thing on both sides. So as long as they started equal, and I'm doing the exact same thing both sides, they're going to stay equal. Remember, it cannot be 0, and in this case, it's because I can't divide by 0. That's not, that's an undefined amount when you divide by 0. So that's a little more specifically why it can't be 0 on this one. All right. Ooh, why isn't it going? There we go. All right. So now we're going to try these 4 problems. We're going to solve for u. So I'm going to look at what is being done on u. Remember, you're always trying to get the variable by itself because I want to know what is u equal. I don't want to know what 1 plus u equals. I want to know what is u. So with this one, we can even think about it. This is a very simple problem. If I know that this side is 1 plus something, and it has to equal 7, because both sides have to be equal to each other, well, what would u need to be to get 7? It would need to be 6, right? Because that's 1 plus 6 is 7. So that's kind of just looking at it. Now, as we get a little bit more involved with our problems and we have more steps, we're not going to just simply be able to look at it and go, oh, I know what it has to be, because we're going to have to do more than one step to get there. But for single step equations, a lot of the time we can just look at it and go, well, what does that variable have to be? What would I have to fill it in with to get this number? So to look at it algebraically, if I'm looking at this is a positive 1, and I'm not looking at this positive actually belongs to the u. It's the fact that there's no negative in front of the 1 means that it's positive. So 1 is being added on the same side as u. So I would undo the 1. So it says, what does u have to be? to get 7. So that was the question I asked, right? I just forgot that I had filled it in there. So now let's practice the subtractive property. So we're going to subtract 1 from both sides because 1 minus 1 is 0, and that means that u is all by itself. So u drops down here, and I have 6. 7 minus 1 is 6. So this is kind of just thinking about it. What does it need to be in order to get the number I'm looking for? And this is the algebraic method. You want to get used to doing the algebraic method because as we get more steps, we're going to start to get 2, 3, 4 steps. We're not going to be able to just look at it and see, oh, this is the number I have to fill it in with to get the correct answer. So we want to get used to doing this way. All right, so now we're going to go to this guy over here. So it says, what does y have to be to get 32 on the left side? So this one might not be as easy because 32, it's a little bigger number. So you'd have to think, what number do I have to divide by 2 to get 32? So with this one, this one's probably not as easy for students to just see that because it's going to have to be a bigger number, and in this case it has to be 64 because 64 divided by 2 gives me 32. So I have to cut that number in half to get the 32. So let's look at the algebraic method. We're going to practice the multiplicative property. It's being divided by 2, so I'm going to multiply by 2 on both sides because any number divided by itself, multiplying by 2 divided by 2, cancels out. It becomes 1, so y is left by itself, and 32 times 2 is 64. All right, so now we're going to look at this one down here. It says, what does x have to be to get 91 on the right side? So again, that one's not as easy because we might not know our multiplication factors all the way up to 91 and 7s. So if you do, yay, very cool. There are games, actually, you can practice on Alex that will help you increase those skills. And those skills make things so much easier. So can't tell you how much I would encourage you to practice those multiplication skills. And division skills, addition, subtraction, all those skills, yes. So with this one, it would be 13 because 7 times 13 gets me 91 because I would have to figure out what do I need to multiply 7 by to get 13. Now I can kind of try to figure that out and, go, well, 7 times 10 would get me 70, so it's got to have to be more than 10. And I can kind of play with it and go, well, 7 times 11, it's going to get me 77. So I can kind of keep going up and figure that out. But I think the division property is a little easier here. I can divide by 7 on both sides because I'm multiplying by 7, and 91 divided by 7 gets me 13. So I think this method is a little easier. It's a little faster than me trying to kind of just mumble or bumble around and figure it out. I hope I'm saying that right. All right, last one here. So we have, what does w have to be to get 204 on the right side? So again, this one's a little different. This one's definitely a little more hard to just picture, I guess, because I have 204 and I had negative w plus 61. Well, how do I get 204 if I have positive 61 and I have a negative number? So this one I think is a little harder to just grab that number out of thin air and just go, oh, yep, I know that it's got to be a very large negative number. And that doesn't include this negative, because 2 negatives make this a positive 143, plus 61 gets me 204. So that one definitely would be a little harder, I think, to just kind of figure out what number fits in there. But if I use that subtractive property, I'm going to subtract 61 from both sides because that's what's being added. So 204 minus 61 is positive 143, and that's going to equal the negative w. Remember, that negative is going to come down with it. And whenever I have a negative variable, I don't want to leave it that way. What I'm going to do is literally give that negative to the other side. So it's going to become negative 143 equals w. Just like we saw up here, it is negative 143, but I think those properties of equality can definitely help us figure those answers out a little easier than just trying to fill in the blanks. Some of them I think are a little easier than others, but as we move forward, using these properties of equality will definitely help things go a little smoother and a little faster. All right, so that was properties of equality. I hope that helped, and I will see you on the next video.